Picture this. You wake up, you turn on the tap, and you don't think twice. But somewhere, there is a SCADA system that controls the chlorine dose. There is a PLC that is monitoring the pressure and controlling the pressure. And there is an HMI that is connected to a network. In many of the countries, this is the least protected infrastructure. Yes, today we are going deep into the water treatment plant, what they are, how they work, and where they are. I'm Ameen Munaf. This is Practical OT Security. And joining me today is someone who lives and breathes in the sector for almost 20 years. Joshua, welcome to the show.
Thank you, sir.
So for those of you who have not come across Practical OT Security before, I'm Ameen Munaf. I'm managing cybersecurity consultant with SIS. I'm based out of UAE. I hold OSCP and I work with IC 62443 and I have delivered several OT security projects across GCC and Australia. The reason I started this podcast is genuinely that I believe practical OT security knowledge is scarce. We don't have enough people with the right knowledge to secure it. And today is a perfect example, the water treatment, a least known sector. So let me hand it over to Joshua. But before we get into technical depth, Joshua, set the scene for our listeners. Who are you? What's your background? And how did you end up in water sector?
Okay, so I literally followed in my father's footsteps. I started working with him when I was 15, fixing water leaks, and following right behind him, seeing this little vial of water, and he would turn it different colors, and I'm like, "What's that mean?" Comes to find out that he was checking out the chlorine residual, and at that different level of color, it indicates how much chlorine residual was in there. And I just became absolutely fascinated with this. I started just working with it more and more. I went to college for a little bit, and then at the time, I realized that I needed to actually help my family more than going to school. So I continued to go in the sector, and this is all I've known as an adult. I mostly started off with groundwater and slowly moved and a little bit of wastewater, and then slowly started moving to surface water, which is a whole different beast from groundwater. And that's what we're going to be talking about today. But groundwater, even though it's simpler, is still still a complex thing, and it would be still something that no one ever thinks about protecting. A lot of these are out in fields. Nobody ever looks at. And that would be something that we need to look at as well.
Joshua, let's make sure everyone's watching has a rock solid understanding of what water plant is. Can you walk us through the different process? What is actually happening the moment the raw water is pulled from a river or a reservoir to the moment it comes out of the tap?
Absolutely. So water plants are 24 hours, 24/7 a day. We never stop. It starts off with coming at the raw source. And this comes from all kinds of different tributaries. Your rivers and everything run off into these lakes. A lot of them are man-made, some of them are natural. So as that runs through, we all know the water cycle. So as it runs through, it hits our lakes. And we have water intakes in. So, and they are typically at the very bottom of the lake where they can have time to settle out all the surface trash. And then there are about 6 stages of water treatment that we go through. And it starts off at the very bottom of the lake where we have bigger screens for logs, rocks, bigger sedimentation, just like you would think of it like any kind of other filtration thing. So it starts pulling that down. But down there, we actually have our raw pumps. So in order to get to these, you have to have divers and everything of that nature. But so we will start pulling the raw water out. And we start doing our treatment process at that moment. As we pull the water out, it'll start coming through and going to what we call a rapid mix. And that's where we start injecting our chemicals. I know everyone's always like, oh, chemicals in the water. We want those. And this is something that we also need to defend. It is typically outside, out in the middle of nowhere, or not in the middle of nowhere, but it's just outside. And so we have chemical pumps adding to that. Typically, it's a disinfectant and a coagulation. And or you're going to ask what coagulation is. Well, we need to the first 3 steps after pulling the water out is almost essentially like you have a bucket of dirty water, right? And you want to set it down. And you come back later on and you have the water clear at the top. In fact, that's what they used to do with water wells. They would pull it out of the ground with a windmill and pull it and put it into the bucket. They come back later and they would have clear water. Well, that's what we need to do, but we also need to do it in a mass amount. We're talking 75 million gallons a day. That is not going to settle out on its own within the time frame that we need. So we start adding coagulants. These are typically a positive charged ion or a chemical, and it sticks to the dirt in the water. There's inorganics and organics in the water. So this is our first step. We're grabbing all this dirt and adding chemicals to it to make it settle out. So that happens at the very beginning, starts happening at the rapid mix. Then we'll have the flocculation step. And that is typically a slow mixing set that we're giving that time to agitate and bind together. Then the next step would be sedimentation. Sedimentation is the longest time that we have. We do want this to set like the bucket, but obviously in a map, but we wanted to do faster, but it still takes hours. So any point of this, you cannot, if you stop at these for 3 steps and you lose water, you're not getting the water back until hours. That's why we have storage tanks and everything. We'll talk about that here in a minute. So we have PLCs coming through on every one of these steps, and they're controlled with the that we have.
So just to crystallize, we have 6 stages. The stage 1 is intake and screening.
Yes.
And the stage 2 is coagulation and flocculation.
Yes.
Then the 3rd stage is sedimentation.
Yes, sir.
The 4th stage is filtration. The 5th stage is disinfection. And the 6th stage is storage and distribution.
Correct.
And you are saying that at each of these stages, there is a PLC or a controller that is actually controlling the actual process.
Yes, several.
Yeah.
Several.
So when we talk about the water treatment plant, we are quite literally talking about protecting the safety of every glass of water that we drink. Is that correct?
Yes, absolutely.
What does actually happen if a plant goes offline?
If the plant goes offline, we have our storage and clear wells, and that starts the timer. We know how much time we have depending on how much the system needs. And some systems we never stop. Other systems we do stop the process because we're full. But at that moment, if the plant stops, it's a timer. So we can't just patch things in the middle of anything like that. It has to be a set time.
Okay. So especially in hot climates like the place that I live in, UAE, right?
Yes.
If the loss of water supply happens in summer, 24 hours we are gone. Is that what you're saying?
Yes.
Okay. So now the sector itself, for example, the company that you work for or the region that you work for, how many people does it serve? How many people are affected at one point in time?
Easily millions, honestly. We're a massive wholesaler and we supply several other cities. So, and they continue to distribute out on their own as well.
So water plants just don't need to be available, but at the same time, it has to be chemically correct, right?
Correct.
So if a plant that's running has a wrong dosage of chlorine, for example, if it is less, there's going to be pathogens. If it is too much, it's going to be chemical poisoning. So it's very critical infrastructure. The integrity is of the utmost importance. All right, Joshua, I've created a Purdue model so that our audience can see what different components we have. I understand that we may not be able to go through everything. So for those of you who are listening to us today, we'd be sharing you the file that we are using today. You could interact with that file and understand what each component does. But I will let Joshua go through those model right away. So this is something that I created with Claude. Thank you, Claude. Okay. Can you see the screen?
Yes.
All right. So we have level 0, level 1, level 2, level 3, so on and so forth. So it's just a hierarchical model showing what components we have at level 0 in terms of the components that are actually controlling the physical aspects of a water plant. So Joshua, can you take us through the level 0 components?
Absolutely. So we'll start off all the way to the left side. So that's flow meters. That tells us how much water we're pulling in and how fast. We need to know that number so we can actually start knowing the chemical treatment that we need to do, because we have to do it at the chemical weight of the water. As far as the next step, pressure and level, that tells us how fast we're moving and how higher we're filling it up. Then the water quality, this is the important one. This is the one that we're monitoring all the time. We monitor the others, but this one is like what we spend all our time with pH, turbidity, chlorine, and total organic carbons. We're maintaining a balance at all times, and water doesn't like to be balanced. It's always fluctuating. So the next one would be PLCs that control the valves and actuators. So they're controlling literally valves opening and closing and the levels. This is also something that we need to keep an eye on, because if something were to say shut off or open up, we could lose critical pressure or have water hammer, and that could cause a cascade effect of water damaging pipes and everything of that nature. Pumps and drives. This is where we get our water from and how we push it through.
So out of all of these things, the most critical component is the water quality related instrumentation components, because these are directly influencing the safety of the water. Would that be correct if I say that?
Yes, that is our direct line of communication with what the process, so we know that we're treating it correctly.
And how are these controlled? These are level 0 components. I know these are controlling the physical process itself, but how are these devices controlled?
So they're typically controlled by several different outputs, depending on how we do it. Or because everyone has there's not a uniform way of doing it. We'll use 420 milliamp. So like 4 would be 0 flow, and that way there's always a signal going through. And then 20 would be the max. So the easiest way to describe that is 4 is 0 MGD, million a day, and 20 would be, whatever your max is. So say it's like 24, it's just so easy math. So you just shift everything by 4. There's different protocols. You have Modbus, you have Field Bus, and Probus, and wireless Ethernet. These are all points that are non-authenticated. They are promiscuous by default, because you can't. Availability is more important than confidentiality or integrity. We need to have it always going at all. So we're not waiting for it to send an acknowledgement and go back and forth. They just sent.
All right.
So
we have different PLCs here. Now let's take the disinfection PLC. What does this do?
So this would definitely be controlling our chemical pumps. So there's several different kinds. They're essentially a diaphragm pump. So at whatever speed we need to do the math, it pumps like a heart, and that's controlling that. It's based off the 420 milliamp in most cases. It's saying, hey, we have 3 MGD, there's some ladder logic going through, and it does the math for you, and it knows the pump X amount of times per minute, and that's injecting our chlorine or other disinfectants.
And what's the protocol that is predominant within water treatment plants? So DNP3, can we say that it is still using the unsecure version of it?
Yes.
Yeah. I'm calling this out because these protocols are designed for reliability. Nobody thought about security when they actually created these protocols. So yes, there are improvements to the DNP3 specifically, but adapting it would take time. Adopting it would take time because the vendors have to support it, the components have to support it, and then you need to have a downtime to actually implement this. So
Yes.
yeah, that's where we stand. All right, now let's go to the next level. So what do we have in supervisory control level?
So this area is actually where most operators spend their time in. This is our HMI, and this is we also we use it interchangeably for the SCADA, but they're not the same. But for most operators, we use them interchangeably. This allows us to. This is the actual visual of what we need to do, and this is where the water quality. This is where we're constantly being vetted. We typically have big monitors almost in every location, actually like watching these levels more than most of all of our other stuff. But this is also another point of weakness too, because we get complacent with watching these. You have fatigue alarm or alarm fatigue, and this is something that Stuxnet abused as well.
Now, what happens if this layer is gone? Do you still run the operations, or do you do you bring everything down? Because, for example, disinfection, right? You do not have an HMI which monitors the disinfection. What's your what's the protocol? Do you stop the plant, or do you continue to run, or do you have some other mechanism to actually monitor these?
So a little bit of both, or all of it. So if typically if these go out, and we have UPSs and everything to be able to obtain. But if we lose the HMI, a lot of times it has safety protocols built in that everything shuts off in a safe way. We're not slamming the actuators and everything. We don't run blind. In fact, a lot of our compliance is that we can't run blind. We don't have a turbidity sensor running and monitoring, not just a scene, but if we lose being able to see a turbidity sensor on a filter, we cannot run that filter. So if we're blind, we're out of compliance and we have to shut off. We do have protocols to where if we needed to run this in an emergency, yes, we have and it's typically full open, but that is like a massive multi-day thing.
Do you usually have redundancy at this level?
Level 2? Yeah, it's the UPSs, and we have extra monitor locations, not just the monitor we have, but they're not our main ones. And so they're like a warm site situation where we would have to build everything back up and go, but they're not being constantly fed, and they may not have everything.
Let's move on to level 3. What do you have at level 3?
So we have the actual SCADA server, and this is where all the PLCs and the filter of the field instrumentation and everything is being directly fed to and processed. It gives us what we need on the HMI, and then it's constantly moving back and forth like most servers. They're typically smaller than what you would see in most server rooms. They're generally only a couple racks, but they're typically in one of the most secure parts of the facility that we have, which is ironic because each one of these is something that should be treated with the same level of security.
And how
So,
about, yeah, sorry,
so,
continue.
so our historian, that we use that a lot for compliance. Actually, we start if there's something wrong, we're able to go back and look at it. But if we get audited and everything, that allows us to go, no, look here, this is what it is, or this is what happens. We are required to do it. And if it's off center, if it's not keeping up on time and everything, we're out of compliance as well. There is a lot of like regulations based upon that the historical servers.
Okay, that's good. And let's talk about the beast here, engineering workstations. What do they do?
Yes. So that is typically where we actually will code the PLCs. That is where a lot of the that's where a lot of the security vulnerabilities at too. That's like one of the golden goose, so to speak, because they're typically they have passwords, everything, but it is not. I don't want to say it's not secure, but it is secure, but it's not nearly as secure as what you expect it to be. But yeah, you can control it with. You could typically even come in there with your a different PLC and feed it like you would like an Arduino or anything of that. You can run the sketch right there on that PLC, and now you have that PLC. It doesn't even have to be out in the field. So now you have this rogue device.
Yeah. So it's if someone compromises that workstation, they could essentially reconfigure all the PLCs or any
Yes,
PLC that it manages.
yes,
With that, we are saying the pressure valves can be changed instead
yes,
of flagging it at a right value, it flags at a wrong value. And instead of setting the right dose of chlorine, we could reduce it or we could increase it. Is that what you're saying?
yes, and shut things off, as well as make us go blind.
Yeah. I used to say this in our consulting practice that it's a crown jewel that is sitting in a park bench, and it's easily accessible in terms of
Yeah,
maintenance laptops. It's not just the station that is set aside, but most of the time it comes in a form of a mobile device, which is a maintenance laptop. So this is something that you cannot control it. Is that the case with water plants as well? Do you have maintenance laptops that you don't have idea of what's happening with it?
yes, actually, they typically are not like a recognized case with a lock, but if just like the water if you could touch it, you can own it. So if somebody were to run off of that, that's a massive thing. It needs to that needs to be controlled at a massive access control.
Hmm. And then the other layers are very typical. We call it DMZ level. It's usually 3.5. But how in your experience have you seen a proper DMZ, or it just a checkbox?
So, yes and no. Ideally, if you ask me, I would have a complete different isolated network at all, not even like subdivided or anything, just completely. But yeah, I've seen just like small bit of firewall in between it all. This facility that I'm working at now is actually really well done, so um, it does have a good security setup. But typically, I haven't seen any real servers in my career. That's not saying that they weren't there. It's more my familiarity personally becoming used to it. But that's just as my knowledge is going.
Yeah. But the right way to do is the level 3 historian passes the data to the DMZ historian, and anything the IT has to fetch it has to get from here. But we all know that this is not the case everywhere. But yeah, it is what we got. All right. And we have the other layers, the level 4 and level 5. What do we usually see there?
This is where like our typical IT systems work, where we can have our like a SOC team or everything, but typically we don't have a dedicated team to that. We might have one or two individuals or a third party to come do it for us. It's not something that utilities typically think of in general. Sure, like further on, like higher up with the HR as well as like finance, they might do it, but our typical in office stuff is not nearly as secure as you would believe it should be. And that's across the field, not at one location.
What is the GIS here? What does this do?
That is like a GPS layout of your pipes and your pressure zones. So it literally is the map to the system. Well, a lot of times we'll use for distribution. They'll go, okay, this is a 6-inch line. Let's bring all the parts and everything. And they are moving towards being more digital. We used to have paper and they would sit in the truck and get torn up, but they are now becoming more digital, and you're able to pull them up on your phone through a webhook server or anything like that. It's really, really a useful tool, but it's also something that you can definitely leverage against. They would have like, there's remote flush valves. So we flush out water. People often think, oh, we're wasting water. But if water is sitting in a pipe for too long, it starts getting that stale, stagnant, and we start creating different chemical reactions with the ammonia building in there, and we start getting nitrates and everything. So we want to flush it out. But and they're moving to a remote system, so that would literally be a map of a remote flush, which is something if you open and close violently, you could cause a massive water hammer as well.
Interesting. From a threat landscape perspective, categorize these as 3 broad categories: nation state actors, ransomware groups, and hacktivists. Let's take ransomware group as an example. They don't have to come to the OT level at all. If they just infect the IT level, your business is impacted. Is that correct?
Correct.
Yeah. Now, from your experience, what do we actually see now? Is there a common Active Directory between an IT and OT, or is the access easily allowed? Do you have remote access, which is frequently seen to these OT infrastructure from IT side? What kind of vulnerabilities do you see? What kind of weaknesses that is often seen?
So, a lot of times, yes, the IT side has remote. Most of the time, we don't have a dedicated one or the other. If you are the IT guy, you are now the OT guy as well, which typically causes like internal conflict too, because why is this guy messing with my stuff? Vice versa. So, yeah, and the scary part about it is as technology is advancing, you start wanting to, make things easier. I would love to be able to see an alarm at my house and go, okay, I know what I need to do. I know what I need to bring to the site. But there's also starts becoming a window to something else, someone else looking at it for a ransomware or hacktivist or nation state actors.
From a defender's perspective, what keeps you at night?
What keeps me up at night is the fact that we treat this our security like a turtle shell. That's what I've been trying to explain to everybody is we have a great outside preventive, like this is great. Well, this is what we want. But once you pass that, there's not nearly as much access control as you would like. Even with like some of the bigger systems, where you should, if you're in a server room, you're monitored the whole entire time. But this is an industrial environment. We have contractors coming in. We have security fences. We have locked doors. But also you see people who get complacent, hold the door open with a fire extinguisher. As a defender, I'm trying to speak out that we need to have a layered in defense. Again, that goes back to being kind of hard on the lower levels because we want our machines to be able to constantly talk to each other and not ask for authentication when we want to change something on the fly, because water is constantly changing.
Okay. Let's talk about real challenges in the water sector from a cybersecurity perspective. Patching. How easy is it to patch your systems?
It's not easy at all. We have things that have been in there since the 80s and 90s because they work, and they don't have there's we don't have a it's not just plug in and plug out, because the whole infrastructure was built upon this. We say there's an actuator that has been there since before I was born, and the pipe is set and measured to that thing. So if that actuator company is no longer available, we have to start piecemealing and pulling up parts. But if not, then we have a whole nother system where we have to break out everything and redo it, and that could bring it down. You would think, oh, I could just replace this one little PLC card, but in reality, it is now a multi-million-dollar part. So we don't tend to patch unless we absolutely have to.
That's certainly something that we see in all the sectors. How about network segmentation?
Network segmentation is really good in general. It's not where I personally would like it. I would like two parallel systems. Where if you need the historian data or something like that, you air gap it with a USB that's access control. It's not always like that in general, but it's typically done by subnetting and DMZs like we talked about earlier. Excuse me.
Okay, let's get to the attack surveys that won't go away. Remote access. Do your vendor need remote access to these OT systems?
Unfortunately, yes. Not saying anything bad about the vendors, but yeah, that's how we do get patches. So third party attacks are something that we have to look at.
Okay. Lastly, to the elephant in the room, budget. You're not an oil and gas sector. So when it comes to the cybersecurity programs or initiatives, how do you take this to the executives? What's the language that we should be using to make them act on it?
So this is something that I'm personally am dealing with, and I don't have a solid answer for, because I'm not there yet personally. I would like to say, hey, look, not being alarmist, but these things are happening, and I understand that budgets are tight, but we need to start definitely dedicating some time to this. We reinforce our gate, but we don't have security on our network. We and a lot of this can be fixed with just training. And I know training costs money, but at the price of at the price that it is, it's probably pennies on the dollar comparison. I haven't really worked a whole lot of budgets in my career, but I can tell you that having a 10, 15-minute seminar of saying, don't plug in the USB kit or USB drive that you found on the driveway would do massive amounts of help.
Okay. What's your top advice for OT security professionals that are getting into the water treatment plant for the first time?
Get to know your operators. Just because you think you're coming from a different point of view does not mean that that guy that's been sitting there for 30 years and doesn't have a college education is dumb. They typically know that system more than the engineers who build them, because they're staring at them 24 hours a day. Get to know them, trust them, and learn from them, and they're more than willing to teach you and talk to you. And we're typically just really nice individuals, and that will go a long way. So basically, yeah, respect both ways.
Okay. If you could wave a magic wand, what would you change in terms of cybersecurity for OT water plants?
An easier way to do layer in the fence at every level without being problematic to everything else.
Mm-hmm. Okay. If you have time, Joshua, I have a lightning round, a quick fire. Are you up for it?
Absolutely.
Okay. I'm going to throw some questions and scenarios. Tell me what's your instinct on it as soon as you hear
Yeah.
it.
Okay.
You walk into a water plant and find the SCADA server running a Windows XP. What's your first move?
If I find that it's running an XP, Windows
Yes.
XP,
Yes.
typically make sure that it's not hooked up to the internet, but that happens in reality.
Okay. I'll take that. Now, a vendor says they need permanent TeamViewer access. What's your response?
I would like to know why they need permanent access to a device that we've already paid for. If they're wishing to send updates, I want to know about them before they send it. So we have some, because we do not have any kind of rollback. If it is all pushed by them, then we don't have rollback.
Mm-hmm. Okay. Let's say one of your HMI is visible in Shodan. What do you do?
So yeah, we would definitely start trying to figure out which one it is and start figuring out how we can isolate that and in an own environment, and if possible, secure it. And we might end up even needing to report that incident.
Okay. Let's say I have a $50,000 budget. What would you do with it in terms of cybersecurity for OT?
So I would start with training. I would start building some kind of layered model that you can talk to the operator. Don't come in with IT. That's not going to go well. Not because we're uneducated, but we look at this is going, that's computer stuff, even though we stare at a computer every day. That would be where you start with education and start building up. Much like I like to make the analogy that like flushable wipes, until for the longest time people would just flush them, and now we're starting to build like, hey, this is causing a lot of problems. Don't do that. And it's the same thing. We need to go, hey, this is causing a lot of problems. Don't do that. It sounds simple, but it really is a massive step.
So training is where you would attack first. Okay, that's good. Joshua, final words. What do you want people to take away from today's session?
I like for people to start treating this more serious than what it is. It is not an isolated issue of that's someone else's job. Security is everyone's job, from physical to digital. We need to work together. We need to learn how to monitor things. And we also need to say, hey, something's not right. If you see something, say something.
Okay. How can people connect with you?
I'm on LinkedIn. And I have my own GitHub. It's called OT Quest, and that's where I've been putting my tools in my notes and reports. And I've been working really hard on trying to make this translation mode between cybersecurity and operational technology. That's really where I've been focusing a lot of my stuff. I'm trying to write these reports like I'm talking to my coworkers.
Thank you, Joshua. This is the kind of conversation I wanted to have. I hope those who are listening to us have gained lots of information on water treatment plan. And thanks for spending time with us, Joshua. And for everyone listening, I hope you're able to take something away from this session. And if you have more questions, please let us know. Maybe you're hearing us maybe from a podcast or from a YouTube channel or from LinkedIn post. Just feel free to post your questions and I'll get you in touch with Joshua. So I'll see you on the next episode of Practical OT Security. Thank you.
Bye. Thank you.
Bye.